All right, so let's go over the solutions for the practice exam. And the first question was based on this graph right here. They told us that g was the integral from 1 to x of f of t dt, and we're looking at the graph of f. The first question just wants us to find the average rate of change of g from -5 to 5. So AROC is something that you've been working with for a long time now. I mean, if you want to go back and talk about slope. Slope is an average rate of change, so it goes way back to algebra days. But using the phrase average rate of change goes back to your pre-cal days, and so this is something you should be able to handle without much help. But some of us made some silly mistakes. Now this is g of 5 minus g of -5 over 5 minus -5. So that's the first thing. And they give you 1 point for demonstrating your knowledge that this is a ratio, that this is a difference quotient, if you will. So if you did a difference quotient like this, even though everything after it was wrong, you at least got 1 point for understanding what you were supposed to do. Now, the problem with a lot of you is I think a lot of you just gave me the output here. So like you thought g of 5 was just 4. You thought, um, sorry, I'm trying to get a color here. So 1, 2, 3, 4, 5 is right here. So you thought 4 was what went here, and then you thought -4 went here, and then over 10. But this is all wrong, okay? This is wrong because the graph is here of f, and they want g of 5, and you put f of 5. You found the average rate of change of f, not of g, okay? So if you did that, let's learn from that mistake. Let's pay better attention to the question, and let's work to get this right, okay? In fact, I'm going to go off to the side here for a moment and work on. So g of 5 is the definite integral from 1 to 5 of f of t dt. So if we just interpret what that means, that's just the area bounded from 1 to 5. So that's the area under the curve here. That's all of this stuff. So I need to find that area. It's just a trapezoid, so I can go ahead and just do the calculations. Clean it up a little bit so I can see it a little bit. We have base 1 plus base 2 times the height divided by 2. That's the orientation of this trapezoid. So 4 here, 2 here, and then the height is 4, okay? So base 1 plus base 2 times the height divided by 2. And so what do we get there? So that's 6 times 2, which is 12. All right, so we know this is going to be 12 minus, and then we have to figure out what g of -5 is. G of -5 is going to be the integral from 1 to -5 of f of t dt. This is how they layer things in on the AP exam to see how well you understand multiple concepts in one question. You have to remember that to work this out, or to think about this in the usual way, you should flip the limits of integration. And when you flip the limits of integration, we get this negative as the coefficient. So this is going to be the opposite of the net signed area bounded between -5 and 1. All right, so what's the net signed area bounded between -5 and 1? So I got to find the area of this triangle right here, okay? And it's below the x-axis, so it's going to be negative. I got to find the area of this quarter circle, again, below the x-axis, so it's negative, and the area of this triangle. And so I got to find those three things, add them together. They're all negative because they're below, and then they're going to become negative again, or the opposite of that. So, oh, in fact, let me get rid of that. Let me go back to black here. So negative. And so that triangle here, that first triangle from -5 to -2 has a base of 3 and a height of 4, okay? Or you can call it -4. That way you account for the fact that it's below the horizontal axis, okay? And so we got that, and then plus, now the area of the quarter circle, it's got a radius of 2, and so it's, pi over 4, because over 4 it's a quarter circle. And then the radius is 2, so 2 squared. And I just got to make sure that I count this as negative. So to do that, I'm going to make it a subtraction problem here. And then for the other triangle, I have a base of 1 and a height of -2 divided by 2. So I get this. And so this is negative. So this is -6 right here. 4 divided by 4 cancels, so minus pi here, and then this becomes -1. And so this is minus -7 minus pi, or this becomes 7 plus pi when I take the opposite. So this is going to be 12 minus 7 plus pi. Whoops. And then all of that divided by 10. And then I got to distribute the subtraction there, and 12 minus 7 is 5 minus pi over 10, and that's the answer to part A. This one question layers many different concepts, and so this is what you're looking for on studying for the AP exam, okay? You want to be able to demonstrate your knowledge through different topics in one question. This is how they're going to ask. These are the types of questions they're going to ask. So an average rate of change, something you've been doing for a long time. So you have to evaluate that. Then they have to deal with integrals. You have properties of integrals where you're flipping the limits of integration, making it negative, interpreting the integral as area bounded by a curve or net signed area, and then doing the geometry to calculate that. This is an excellent question, and you should expect something like this on the AP again. All right, now for part B, it said to find the instantaneous rate of change of g at x equals 3, or state why it doesn't exist. And again, a lot of you are not thinking about this clearly when you're going through it because you forgot that you're looking at the graph of f. And so a lot of you saw the sharp turn right here at 3, and you said, well, g prime of 3 doesn't exist, okay? And you're tricked into thinking that because, again, they designed the question in a way that they're trying to see who is paying attention and understands what they're doing. Some of you understand this stuff, but aren't paying close enough attention, okay? So you're looking at the graph of f, okay? I'm not looking to see if there's a sharp turn here. I need g prime of 3, so I got to do some fundamental theorem here, and that's going to be on the AP exam all over the place. In fact, it was essentially, well, we didn't use it up there because we used geometry, but anyways, this is an example where the fundamental theorem is. First, let's find g prime of x, okay? Fundamental theorem, remember this is g right here. Fundamental theorem says that g prime of x is just going to be f of x. So g prime of 3 is just f of 3. And if I'm looking at the graph of 3, f of 3 is the output right here. That's just 4. That question is that easy, ladies and gentlemen. And a lot of you got it wrong for the silly mistake of not paying attention to what the graph represented, and you thought about it incorrectly, okay? You could do better, okay? Let's pay closer attention, think clearly, go through the concepts, and apply them systematically to answer these questions. For part C, they're asking on what intervals is G concave up, okay, if any. And so to figure out where G is concave up, typically we use the second derivative, but we also learned about it from the first derivative. Now remember, G prime is equal to f of x. And we said when G prime is increasing, or the derivative is increasing, then the graph is going to be concave up. So we look for where this graph is increasing, and that'll give us intervals where the graph of G is concave up. They want to see that you make the connection between this graph and G being concave up. So you want to reference that f is increasing. Now you can't say that f prime is positive, but you just got to make all the connections there. So you want to say that G prime is f, and then G double prime is going to be f prime, and where f prime is positive, then G is going to be concave up. But it's easier to just say where f is increasing, okay? Well, where is f increasing? So, well, f is increasing right here, okay? What's that? That's from -5 to -2. And then it's also increasing from here to here, and that's from 0 to 3. So you can just say that G is CC up on the, and they say on open intervals, just list them as open intervals, -5 to -2, union with 0 to 3, because F is increasing on those intervals. It's as simple as that. Now for part D, I don't think a lot of you read part D carefully enough. And I understand in a time test that you guys are rushing through things, but you give yourself a chance to be correct by making sure you understand the questions. So sometimes you're going to save yourself a lot of headache by reading a little more carefully, slowing down and making sure you understand it and just go through the concepts rather than just trying to rush through and write anything down and getting it quote unquote done. Okay. Done well is better than just done, obviously. So don't rush, get it done. I'd rather have you get 3/4 of the way through it and get maximum points on those 3/4 than get all the way through it and do, poorly on half of it. You'll do better. Okay. So for part D, it says to find all of the x values in this open interval -5, 5, at which G has a critical point. And then it says to classify each critical point as the location of a local max, local min, or neither, and justify your answer. So we need to do several things here. We need to find critical points for G, where that's where G is, it's the derivative, where G's derivative is 0 or undefined. And then we need to look for at all those points and see if we have a local max or local min or neither, and then justify the answer. All right, so let's go with, oops, excuse that. Okay, so remember G prime is equal to F, okay? So first of all, on this interval here, F is never undefined, okay? So there's no critical points from that. Now, when does F equal 0? Well, F equals 0 at 2 points, okay? F equals 0 right here at -2, and F equals 0 right over here at 1. So F equals 0, I'll just keep it in green, I guess, when X equals -2 and 1. Now, the point structure for this is to identify that you need to look when F prime, when G prime or F equals 0. So they're going to give you points for saying, for just saying this, for writing this F equals 0, you get a point. And then you get another point for identifying both of those values, okay? And then after that, now you have to classify, okay? So let's go through each one. What's happening at X equals -2? Well, if we're using our first derivative test, the first derivative has to change signs for there to be a local extrema there, okay? Local max or local min, right? But right before -2, the graph of F is negative. Right after, still negative, okay? So you'd say there is no local extremum, or you could just say min or max, and just say because G prime, which equals F, does not change signs at X equals -2. Now, what was happening at X equals 1? I'm going to have to scroll up in a minute, but let's get the answer down first. Well, right before 1, G prime, which is F, is negative. Right after, it's positive. So when graph changes from negative to positive, that means we're going to have a local minimum, okay? So at X equals 1, you could say G has a local min because G prime, which equals F, changes from negative to positive. Try not to write a negative symbol and a positive symbol in there. At least if you're gonna, be lazy like me here, you can abbreviate. That's at least more readable. But if you put a negative symbol and then a plus symbol, they should accept it. But let's not risk them being particular about the you not writing the words down. So give yourself, full chance, write the words down. Um, There you go. That's not that hard of a question. We did stuff like this a lot in chapter 4, so you should be able to handle that. And I know you can. Just got to make sure you brush up and practice and think clearly and not rush through things. It's going to cause you to make silly mistakes. Now for number 2, it starts off by giving you an implicit equation, 2x squared plus 3y squared minus 4xy equals 36. And in part A, they say show that. They're giving you the answer for the derivative. You have to just show where that comes from. So you just got to differentiate the implicit equation that they gave you and then do the algebra to show that your implicit equation is simplified down, or its derivative simplifies down to this. A lot of you are confused by that. Some of you try to take the antiderivative of dy over dx, which is not what they wanted you to do. And some of you did some other stuff that I can't recall off the top of my head. But again, the point is they're giving you the answer. And the reason why they're giving you the answer here and then having you show the work is because you're going to need that relationship later. And they don't want to, have somebody who can't find dy over dx not be able to answer a question in part B where you're going to need to be able to have the derivative. Because maybe you can't do the algebra here, but you understand how to do this part. And they don't want to penalize you on part B by not being able to answer part A. So that's why they're giving you that. And maybe even for, and for the same thing for part C, they don't want to penalize you for not being able to, if you can't do part A, penalizing you also then in part C because you can't get the answer to part A if they just ask you to find dy over dx. So they do this sometimes because they don't want to penalize somebody multiple times. If you can't do part A, you can still answer the rest of the questions. But in part A, you're just taking the derivative implicitly with respect to x of that equation and then doing the algebra to show what dy over dx equals. So here's this. And so we're going to differentiate both sides with respect to x. Some of you put a dy over dx here, which really annoyed me. I hope they don't penalize you for that. I don't think they would if you do the rest of it correctly. But mathematically, it's not correct. But anyways, okay, so we get this. So this is going to be 4x. We're differentiating with respect to x. So that's, just 4x plus 6y times y prime. Now, a lot of you messed up this minus sign here, and they do this on purpose to see if you can not mess up the algebra with this negative here and the product rule. You have to make sure you distribute. So you could do this minus 4 and then do the product rule in parentheses here, or you could distribute automatically. This is going to be y plus x y prime. Derivative of x with respect to x is 1 times the second factor y plus the first factor times the derivative of the second factor. Of course, that's got to equal 0 because that's the derivative of a constant. Now, I didn't write dy over dx is in here, but you write y primes, that's fine. You just got to solve for y prime now, which is your dy over dx. So let's do a little bit of the distributive property here like this. The terms that don't have a y prime, that's this term and this term, will subtract or add, get them to the other side. And the terms that have the y prime will leave and we'll factor out the y prime. So when I factor out y prime, I'm going to get, from those two terms, I'll get the quantity 6y minus 4x, and that's going to equal 4y minus 4x when I add this and subtract this. And then from here, y prime, which is dy over dx, is 4y minus 4x over 6y minus 4x. And then here, I could factor out a 2. I want to make this look like their answer because that's what I'm trying to demonstrate. And I can factor out a 2 down here. Whoops, it becomes a 3y minus 2x here. These cancel. And so dy over dx is equal to 2y minus 2x over 3y minus 2x. So they just want you to see you can do that. And they're going to give you points for showing the product rule and doing some of the algebra and verifying. So that's what part A was asking for. So for part B, it says to find the slope of the tangent line to the curve at each point on the curve where x equals 6. So if we go back to, slope of the tangent line, it's easy. We just got to plug in numbers into dy over dx. But the one challenging problem with this, I guess, if you're not thinking clearly, is you have x is 6. You got to figure out what y is, though. So where am I going to get that value? Well, this goes back to the original equation, wherever that is, way up there. I have to figure out from that equation, 2x squared, it'd be easier if I do this, plus 3y squared minus 4xy is equal to 36. I'm going to plug in x equals 6 here and figure out the y values that go with it, and then I'll plug in 6 for x and the y values I get, and we'll go from there. So 2 times 6 squared plus 3y squared minus 4 times 6 times y is equal to 36. So this is 72 minus 3y squared minus 24y is equal to 36. And so this is a quadratic. I'm going to move everything over to that side. So I get a positive 3y squared plus 24y is not equal to minus 36. When I subtract 72, 36 minus 72 is negative 36. I could divide by 3, so that makes the numbers smaller. Looks like this. And then factor. Did I make sure? It's got to be a 6 and 2. That doesn't seem to work, though. Oh, let me go check for any mistakes. There it is. This should be a plus 3y squared. Silly mistakes. Now, see what happens when you try to go too fast? Even I make mistakes when I try to go too fast. That's why I tell you guys to try not to do that. And then this becomes this. And so then when I divide by 3, we get this. And so the y minus 6 and y minus 2, that worked out much better. So I got 6 and 2. And so let me scroll back up. So I have my slope in front of me. So at the point 6, 2, dy over dx is going to be 2 times 2 minus 2 times 6 over 3 times 6. Nope, 3 times 2 minus 2 times 6. Now you can leave it like that if you want. But let's do a little bit of arithmetic. Honestly, ladies and gentlemen, don't bother to simplify. Plug it in correctly and then move on, okay, on the AP exam. So that's 4 minus 12, which is negative 8, and then that's 6 minus 12, which is negative 6, and so you get 4/3. And then at 6 comma 6, the slope dy over dx is going to be 2 times 6 minus 2 times 6, which is 0, over 3 times 6 minus 2 times 6. Doesn't matter what the bottom is, but that's 18 minus 12, which is 6, so that works out to be 0. Some of you wrote the equation of the tangent line here, but it said to find the slope. I think they'd still give you all the credit because you have the slope there, but don't bother to waste your time writing the slope or the equation when they only ask you for the slope. So for part C, it says to find the positive value of x at which the curve is a vertical tangent line. Show the work that leads to your answer. So if we're looking at the slope here, the vertical tangent line occurs, well, any vertical line doesn't have a slope, so it doesn't exist. And so we're going to look for where this does not exist. So where does this not exist? When the denominator is equal to 0. Provided the numerator is not equal to 0 at the same time, which is not going to happen anyways here. But if we solve this for y, we're going to end up with, add the 2x and divide by 3, so we'll get 2/3 x. And this doesn't give me the answer to the question. It gives me a relationship, but not every point on that curve or on that line, y equals 2/3 x, answers this question. I only want the ones that are on that curve, so I have to do a little bit more work, okay? find the positive value of x. And they're indicating there's only 1 here as well. But I'm going to need that original equation, 2x squared plus 3y squared minus 4xy equals 36. And then I'm going to plug this in for y and solve for x. So I'll end up with 2x squared plus 3 times 2/3 x quantity squared minus 4 times, no, it's 4 times x, and then times 2/3 x, and that has to equal 36. And this is just going to be a bunch of algebra. Hopefully I won't go so fast and screw it up. All right, so it's going to be 4/9 times 3 should be 4/3 x squared minus 8/3 x squared is equal to 36. If I want to get rid of my my fractions here, I can just multiply by 3. So I get 6x squared plus 4x squared minus 8x squared is equal to 108. And then that's 10 minus 8, which is 2x squared is equal to 108. So x squared is going to be 54. So x is plus or minus the square root of 54, but they wanted the positive value, so the square root of 54 works. That's 9 times 6, so it's 3√6 if you want to put in simple radical form, but don't bother, just answer it like that. So for part D, it says let x and y be functions of time t that are related to this equation at time t equals 1. Now they're giving us a bunch of values. X is 2, y is -2, dy over dt is 4. They want us to find the value of dx over dt at this same time. So we got to differentiate this equation now, though, with respect to t, not with respect to x, like we did earlier. And when we differentiate this with respect to t, and we'll be able to plug in these values here. There won't be any t's, but this is at t equals 1. All of this stuff is true. And then we'll be able to solve for dx over dt, or x prime, if you decide to write it that way. So I'm differentiating with respect to t. So the derivative of 2x squared with respect to t is going to be 4x times, I'll use their notation, dx over dt, plus 6 times y times dy over dt, minus 4 times, now the derivative of x is dx over dt times y plus dy over dt times x. I'm just doing the product rule there, and still differentiating a constant on that side. Now, instead of trying to solve for anything, you can. I'm just not. I'd prefer to start plugging things in. Let me plug in numbers here. I know that x is going to be 2. I'm looking for dx over dt, so that's just remain as that. I know y is equal to -2 and dy over dt is equal to 4, so I'll plug those in. Minus 4 times. I'm still looking for dx over dt. Y is -2, so I'm just going to commute that order there. Dy over dt is 4, x is 2, still all equals 0. And there's only one unknown here. It's in a couple different spots, is dx over dt, but just arithmetic, not basic algebra, which is just advanced arithmetic. Minus 48, so that's 24 times 2. And then I'm going to distribute here. So I'm going to get a plus 8 dx over dt. This is 8, and then times -4 is -32, because I'm writing and talking, and that's a challenge for me. 8 and 8 is 16, so this is 16 dx over dt. -48 and -32 is -80, but if I add that to the other side, I get 80. And so when I divide by 16, we get 80 over 16, which happens to be 5. And that's it. Ladies and gentlemen, you could do so much better. Some of you need to pace yourself a little bit better. Some of you need to read the questions a little bit better. Many of us need to make sure we understand the graphs that we're looking at. And then we just need to work the concepts. The concepts are your guide, okay? So think through the concepts and you'll be able to handle this. I know you can. Let's put the effort into it now, 2 weeks, so we can have this accomplished and you can have success and no regrets and feel good about It's been a difficult year now since we're doing this distance learning stuff, but you guys can do this. Let's go study.